And I turned the AI on too.
Ujú.
Okay, let me share my screen real
Yeah.
quick. Okay. So let's start with an activity again. This time we'll just make it interactive between the three of us. If I give you this like a broken calculator and ask you to utilize this broken calculator, um, where you come up with an equation that the result is 33. The numbers that are available in this broken calculator is 1, 2, 5, 6, 9, 8, 7. And the operations that you can use is division, multiplication, and subtraction. Those are the only ones available. Can you come up with an equation or multiple equations that will come the output as 33?
Okay, thank you.
So you can
Yeah,
translate it and you both think like you're on your own. See if you can come
okay.
up with. Mhm.
Ok. Dice que ahorita pensemos, o sea que esta va a ser una actividad para nosotras, que ver que con estos números que existen aquí, el 7, el 8, el 9, el 5, el 6, el 1 y el 2, qué tipo de operaciones, ya sea la división, la multiplicación, la resta, not subtraction, right? I'm sorry, addition.
Addition. Yeah,
Addition,
no
no.
addition.
No,
Mhm.
no sumas, solamente restas,
Mhm.
multiplicaciones y división, que nos lleva a 33. Que pensemos en eso. Pueden ser todas, una o varias.
Bueno, a ver, 33.
Ujú.
Me quito el 3.
Like,
Me quito
let
el
me
3.
know whenever you're ready if you like, but both of you think separately, okay? Don't share your thoughts.
It should be division, right?
You
Or,
get to pick. You can, there's no right or wrong answer. As long as you come up with like 33 by using combination of division and multiplication,
okay,
subtraction, or you can just use one only.
o
See
sea
if
que,
you can come up with it.
okay. Puede ser lo que sea división.
Entonces que iniciamos con una multiplicación, 6 por 7, y al resultado le restamos.
But it's just one operation, right?
You can use multiple operations, so you can do multiple steps to get the 33, and you can also
Ah,
try just using one operation and one equation to get the 33. It's a
so
really up to you.
it can be multiple operations. Okay.
Mhm.
Okay. But you have to use those numbers and
Yeah, those are the only ones available. Everything else is
okay.
broken. So,
Okay. Sí, sí, está bien. Ajá. Sí, sí, exacto. Pues sí.
do you want me to talk about it?
Yeah, we got it. So it's like
Okay.
6 times 6 por 8, 48, y luego
Ujú.
restarle, ¿no?
Sí,
48 menos, pues para que dé 33.
15.
Ujú, exacto. Y así, ¿no?
Sí.
So we
O sea,
got the first one, so it's 6 times 8, it's 48. Subtraction, 15. Yeah, 15, exactly. But that's
Yeah.
the first one. That's the first one. We keep going. Hay que ver cuáles
Yeah,
otros.
that's okay. Like, did you both come out with this one? The same one?
That was the first one. Yes, that was
Okay.
the. Ajá.
Yeah,
Esa
the other ones that could
fue-
be is like 66 divided by 2,
60
33.
divided by 2. 6 por 6, 36.
Ujú.
Menos 3, ¿no?
Pero no hay
Ah,
3.
no,
Yeah.
no. But 6 times 6 is 36 divided
Mhm.
by 2. No, divided by 2.
Or
That work, right? No.
look, you don't have to divide. You're so close. What operation can you use to get to that? So is 36 bigger than 33 or smaller than 33?
No, it's bigger.
Right?
36.
How much bigger is it?
3.
Yeah, so we need to take away 3. In order to take away, what operation can you use? Subtraction.
Yes, but
And
there's no 3.
yeah,
Bueno,
but what other numbers make 3?
Ah, okay. So then we add 2 plus 1.
But you don't have
No,
addition.
we don't have subtract addition. Then how? Ah, okay. So, ¿qué otros números hacen 3 de ahí?
ujú.
So you
So,
can do
estamos.
36
5
my,
minus 2 is 3, right?
yeah, but you don't have
5.
addition. Yeah,
Ajá.
to go it.
O sea, 5 menos 2 son 3, entonces ya está
Oh, yeah, 5 minus 2 is 3. 11 multiplied
33
by
tiene que quedar.
3 is 33.
Tiene que quedar
Yes.
33.
Sí, por eso.
Ajá,
Ujú. Ahí está. O sea, 5 menos 2 son 3 para poder hacerlo.
ya.
Ujú. O sea, no hay
So,
ningún. Ok, yes.
so, um, so look, you already come up with multiple ones. I've been taking notes. So first you said 6 times 8, 48. How,
Yes.
48 minus 15, 33.
Tengo 3
So you
operaciones.
use like multiplication and subtraction, right?
Yes.
And
Yes.
then you notice the connection between, you notice that the 3 is repeating in this two-digit number, and you need to get the 3 somehow, and you notice that the difference between 5 and 2 is 3, and you can use multiplication. 11 multiplied by 3 is 33. Another one could be 66 divided by 2, 33. Or 99 minus 66 is 33.
Sí, pero
99 what?
no hay
99 what?
3.
99 minus 66,
66 is 35.
33. Or 88 minus 55 equals
88
33.
minus 55. Oh,
Ah, sí.
yes, exactly. Okay.
Yeah,
But
yeah.
88 minus 55. Oh, okay. Then, okay, ya entendí. Si no tenía, o sea, podíamos hacerlo sin sumar. O sea, era usar esos dígitos. Okay.
Sí, porque ese sí sumamos, o sea, ese no,
Sí.
no cuenta.
Sí. Si realmente no sumamos, o sea, no es sumar, sino usar los números. Yo creo que yo realmente me enfoqué más en las operaciones.
Ya.
¿Tú?
Pues yo estaba buscando utilizando esos números porque vi uno y dije, no, este no, porque no hay 4.
Claro.
Estaba utilizando un 42, pero dije, no hay 4, entonces no puede ser.
We were figuring out what to do. We
No,
were thinking. Yes,
I know. It's first it feels like, what is this? Then the more you think about it, it
yes.
just pushes you to think certain way, because we're more prone to, when it comes to operations, we call these like addition, subtraction, multiplication, division. We call them number operations, that you are using these tools to operate between the numbers. Like you, if that makes sense, you're making connections between the numbers. And that's why we call them number and operations, because you are using them as a tool to put it together, almost like a doctor you're operating on, taking it away, dividing it, multiplying it. So you are like doing a magic kind of thing, right? Depending on what the operation is. So when I give you limited numbers and limited operations, our brain is, because I want you to think about more advanced operations like subtraction, division, and multiplication. Addition comes more natural to us, and that's why we're always thinking about adding numbers together first. And it's kind of harder to think about using other operations. You translate, right? Sorry, it's a lot.
No, don't worry. No, o sea que básicamente quiere que pensemos en todas las posibilidades de operaciones que se pueden hacer con los números, porque pues son infinitas, ¿no?
Claro.
O sea, Yes, perfect.
Yeah, and that's why your brains were first going into, oh, like there's no three, there's no like, oh, there's no addition, like three times this I could have done because it's easier, right? And the I like these broken calculator activities once children have fluency with addition and you want them to use other operations because our brain is more prefers to do additions than other operations, then you're like limiting their ability and also challenging them productively to use other operations and see the connections between the other operations other than addition.
Wow. Dice que esta actividad es excelente que porque el ser humano tiende a hacer sumas. Entonces, esta actividad pues se invita a que los niños hagan otras
Otras
operaciones,
operaciones.
divisiones, multiplicaciones, restas, pues para que sigan desarrollando. Excellent. How old do you start doing this activity? ¿A qué edad
So
empiezas?
this one will be more third grade and up activity because like you have the addition, multiplication and division. So this is more like older kids. The
Okay.
ones that are more appropriate, I have like for younger kids some visuals in here, hyperlinked that you can do with all grades, honestly, as long as can starting first grade, I will say. Um, but if you're doing with a first grader, don't use the division and multiplication, just do addition and subtraction.
Esa la resta, pero sí lo
Bien.
puedes hacer. Excellent.
Yeah, and so there are links in here that gives you more additional activities
Okay.
that you can use like as a using like a broken calculator that are across different grade levels.
Perfect.
Esto digo,
And
llegó a cálculo mental, ¿no?
Candy is asking if this will help to mental,
math.
mental math.
Mm-hmm.
Does it help
Yeah.
or not?
Por ejemplo,
No,
variar,
this
¿no? Resultado que me dé 2.
Yeah, this will help. You can ask children to have their opinions, and then they can, once they have one idea how to get there, they can do. Or you can also give them pencil and paper or like whiteboards where they can write their thinking. So it could be mental math, but it doesn't have to be. It could
Yeah.
be like written component, but it could be like a small group discussion where they have their notebooks in their hands where they can
Yes.
keep track of their thoughts.
No,
Yeah.
you got it. It's actually, they need to write the operations. No, que sí
Mm-hmm.
pueden escribirlo. O sea, que sí.
No, no, sí es que lo escriban,
Y que te lo
pero
hagan.
pero ellos tienen que pensar de qué números utilizar para llegar al resultado.
Sí,
A eso me
exacto.
refiero.
Sí, pero que sí lo tienen que escribir
Ok.
y que te tienen que contar, pues, qué están pensando.
Ujú.
Sí. Okay, so you say first grade can do it, but just
Yeah,
to,
as long as you don't have multiplication and division in there, you need to
okay.
block those out
Okay.
because they are mainly working for kindergarten. And I wouldn't do this with a kindergartner, like maybe older kindergarten, but I will do first grade and up. And depending on what operations that they learn, keep them available. What they didn't learn, hide them.
Exactly, depending the literacy they had before, right? I mean, this is pretty, I mean, this is much more advanced,
Yeah,
no? Okay.
yeah.
It's
But
much
this
more
is more for us
advanced.
to like get our brains thinking about the connections between different, so it's
Yes.
more like an adult learning experience for us for the moment. Because when you think about the numbers that we chose, um, like 66 divided by 2, 33. So we're thinking about multiples, like half or like multiple of like 33 is 66. If I divide 66 by 2, it's 33. Or 99, 66, 33. So the help you see what depending on what operation that you use, you engage in different number facts, operation facts, which are doubles, also could be halves when you're doing division. So double of 33 is 66 with multiplication. Half of 66 with division is 33.
La mitad de 66 es 33 en una división. Okay,
Okay.
thank you.
So one of the common missteps that we take as educators when we're teaching number and operations to children. We often focus on procedural fluency over conceptual fluency. And what I mean by procedural fluency is, or rote memorization, is that we're trying to teach them the algorithm without helping them make sense of what they're actually doing when they're using a specific operation. Like, example of this will be like this. When you're
Por
doing, go ahead.
ejemplo, que uno de los problemas que tenemos es que enseñamos a los niños a que se memoricen las cosas sin que ellos comprendan el algoritmo y la comprensión del significado de los números. Yes.
So one of the like common example of this, for example, we never often explain children what operations are we using and what is their purpose. Like, for example, when you're adding two numbers together, it's the collection gets bigger. Adding means that it makes the number bigger. When you add two numbers together, the resulting number was going to be bigger than the other two numbers that you're adding, right? Or when you're taking away, that means that the set is getting smaller. You take away, meaning that you subtract. When we do multiplication, we're looking at how many times a number repeats in another number. But oftentimes children don't understand it because they try to memorize the times table. 5 times 5, 25. 5 times 6 is 30. But they don't understand that when I say 5 times 6, it actually means 6 repeating 5 times, or 5 repeating 6 times. And what does that, if we repeat that multiple times, what will be the end result? But oftentimes children don't understand that times tables is looking at a set, how many times it's repeating in a larger number. And division is the opposite of that. Like in a large number, how many groups exist if each group was a group of 5? For example, when you divide 30 by 5, what you're actually doing is you're trying to understand if there was a group of 5, how many groups of 5 exist in 30? So when I divide 30 by 5, the answer is 6 because it's 6 times a group of 5 is repeating in 30. Does that make sense? But oftentimes we just teach them the algorithm. So when you have 30 divided by 5, we teach them, you look at the first number, 3. Is there any 5 in 3? No. What about 30? How many 5s in 30? And I count up like 5, 10, 15, 20, 25, 30. Like how many times? Like 6. Okay, write 6 in there. But we don't really conceptually explain them what they're actually doing, but we just move through the algorithm of where they are, what they're doing without explaining to them. Good? Okay. And if we want to build the conceptual understanding around number and operations, it's really, really important. We start with concrete materials first, and then move on to visual representations, and then move on to abstract algorithm last. Start with the concrete materials where if they are learning about addition, for example, you say, what is 5 plus 6? Don't do it with the numerals where you're writing 5 plus 6. First, start with you have 5 apples here, you have 6 apples here. If you put it all together, how many would you have? So they visually see that two groups are coming together and creating a new set. And the new set is bigger now because we added two numbers to one another. And once they build that fluency with the concrete materials, then you can move on to pictorial representation where you can read the problem and they can draw their thinking, where like with apples or like dots or whatever that they use. And then they can count them out and say, there are 10 apples now. But then once they have fluency between these two steps, the concrete materials and visual representations, then move on to say 6 plus 5 equals 11. Yeah, okay. So the big ideas related to operations are kind of focusing on three main areas, regardless of what operation that we're talking about. So the first one is, hold on. Oh, my charger's like stuck. Changing sets, comparing sets, and number composition. So we're gonna look at all these like big ideas and what did they look like across different operations. So we'll start with the changing sets. So the big idea is this, adding to or taking away. A collection can be made larger by adding items to it and made smaller by taking some away from it. And that's related to both addition and subtraction. That it's important that whenever we're teaching children the rules related to addition and subtraction, we emphasize that taking away means the collection gets smaller, adding means the collection is getting bigger. So let's look at this clip. So where the child is, and this is a kindergarten child, and doing some mental math. And this is an example of how I say, like doing, especially with the younger kids, doing more concrete addition and subtraction activities rather than just talking about it or by using the numerals and the traditional algorithm. So let's look at this one, how the child is doing the mental math by reviewing these concrete materials as they're moving in and out. Okay? Let me share my sound too.
How many bears do I have here?
4 bears.
Okay, and these 4 bears are all going to go into the cave. Okay, so how many bears are inside now?
4.
Okay, and they're having so much fun that 2 of their friends are going to go into the cave again as well. So how many are there now?
The 2 plus 4 is 6.
6. Okay. And here comes one more bear who says, I want to go in there. So how many are in there now?
I know, easy, 7.
So I'm going to put 7 in here. And 1 is going to go home.
7 and 1 went home, and then it's gonna be 6.
There's 6 in there. Do you want to see to make sure that there's 6?
Yeah. 1, 2, 3, 4, 5, 6.
Okay. But the mommy called 2 more home.
The mom called 2 more home, and there were 6. And then it'll be 3. 3 bears in the cave.
3 bears in the cave. There were 6 and mommy called 2. Do you want to check?
Maybe there's 4.
Maybe there's 4? How can you be sure that there's 4?
Because if the mommy called 2 to go home, then 4 are in having fun.
Okay. What do you think about this one and this activity? Do you have any questions or thoughts, or do you want me to talk about it?
Y el niño está expresando sus ideas también, o sea, está analizando y investigando.
She says what she watched, but for me, my question is that this child probably had practiced before the 10 number or the reckon ren, right? Before.
Yeah.
before he
So
came
this
here,
is an older
right?
kindergarten. Yeah. So
Yes.
he
So
definitely have fluency between numbers up to 10 that he can move back and forth by using visuals and
yes,
mental math without like
yes.
touching. But
But
think
he
about the,
practiced already.
yeah,
He practiced
yeah.
already. Okay.
Yeah, so this child, like, the problem that was given to the child was a meaningful problem, right? The kids are going for a sleepover, and then some friends came. Now there are more friends, like two more friends came. So how many friends now in the
It's
the
applied to their life as well. That's the point
yeah,
as
their
well.
personal life. Exactly. So
Okay.
that's another common, especially with when we're teaching number and operations, like ideas of number and operations starting in kindergarten, the concept doesn't change. So the idea is still the same, that we want to emphasize as we are putting things together, sets is getting bigger. As we're taking away, sets is getting smaller, right? So with kindergarten, you focus on numbers up to 10, most 20. In first grade, you focus on numbers 100. In second grade, you focus on numbers up to multiple three-digit numbers. But the idea doesn't change. It's just the numbers keep getting bigger that the children are working to do addition and subtraction. But the
One
concept doesn't change.
one second,
So,
sorry.
yeah.
On first grade, it's up to 100, and second grade, it's three-digit number. Ah,
So,
okay.
so
Okay.
in first kindergarten, you want to do additional subtraction within 20, and then
Mm.
first grade within 100, and then second grade and up, multiple three-digit additions and subtraction, three-digit and two-digit numbers, adding and subtracting. Could be like, what is 144 minus 22? That's the second grade question.
In kindergarten, you say up to 20
Mhm.
subtraction and addition.
Correct.
Okay, let me just translate one second.
Within number 20.
Ok, within number 20.
Mhm.
O sea, lo que vimos ahorita con este niño es que este niño pues ya había practicado el Requenren, el ten number, él ya tenía bastante experiencia y también, bueno, él ya sabía lo que era, ya había manejado de distintas formas hasta el número 10. Entonces, lo que dice Vilga es que ya a partir de primero de primaria, ese niño era de kinder, a partir de primero de primaria es hasta el número 100. Y ya después de segundo en adelante, a partir de segundo en adelante, son números de 3 dígitos.
Ya nos entendemos.
Thank you, Vilga.
Yeah. So again, the idea is the same that whether you're teaching three-digit additions or two-digit addition or subtraction, you want to keep focusing on that as we're doing subtracting, the numbers are getting smaller. As we're adding, whether it's a two-digit, three-digit number, the collection is getting bigger, right? And as we're doing that, it's important that we find ways to make the word problems that we're introducing to children are meaningful to their lives. Like in this case, the friends are coming over for sleepover. This is appropriate for kindergarten. Maybe a first grade, there will be something more appropriate. Maybe it's going to be about like Minecraft cards or whatever. That, oh, like you have like 10 Minecraft cards, and then your brother gave you, like your friend shared like 20 cards with you. Like, how many cards do you have altogether? Rather than just saying, oh, you have like 5 apples. Now I gave you 10 apples. How many apples do you have? No one is walking around with 15 apples. It's just like it doesn't make sense, right? Like, find ways where we are helping children engage these like adding and taking away experiences through meaningful problems. Yeah. Okay. And it could be another one could be like, oh, like we have a birthday party coming up. Like we have like 10 friends in the classroom. So if you want everyone to have two cupcakes, how many cupcakes should I order from the bakery? You know, and that could be another meaningful too. That's like, oh, this is for us. We have a birthday party coming up. Yes, we have 10 friends, and we want to make sure that everyone has two cupcakes. How many cupcakes should we bake, order? You know, those kind of things could be good questions to ask too. Um, okay. And regardless of the age, always start with the concrete then we'll move to visual representation, and then move on to abstract. So when you're adding, changing sets either by adding or taking away, make sure to always start with the concrete. For example, in this kindergarten and pre-K level 2, counting bears are great because you have a small number that you're working with. It's easy to see, right? So in first grade, you can use base 10 blocks to move things around. And you can use the base 10 blocks again with second grade too. So when you're doing like larger number addition and subtraction, that doesn't mean that they are ready to do abstract. Always when you're, because it's cognitively more demanding than like doing up to 20, right? Doing up to 100 now. So bigger numbers. So give them those 10 base 10 blocks first, put it together, take away so they can see the quantity changing physically. And then move on to visual representation where they are drawing their thinking. And then move on to the traditional algorithm where you have the numerals and they're doing the subtraction.
So what you're saying is that even if they are in second grade, they can use 10, 10, 10 to understand the concept. That's what you're saying?
Base 10 blocks, not 10 frame, base 10 blocks.
Base
Do you
10
remember like I have I think I have the visual. Let me pull the
Nos va a
presentation up.
enseñar cómo lo hacen.
Let me go to the manipulatives real quick. Okay. These are the base 10 blocks. So you remember there were like towers and singles. So
¿No? Tú tienes, ¿no? Yes.
you use
Excellent. So
this
it's
with
not the
first
10 frame, it's the 10 blocks. Okay.
base 10 blocks.
Ah, se llaman bloques de 10 estos. Sí.
It looks like
el
this,
marco de 10 es el otro. Ujú. Okay.
base 10 blocks. So you start with the counters, then you move on to 10 frame. And then with the older kids, first grade and up, you use base 10 blocks. In kinder and second grade, late first grade and second grade, you move on to that abstract, which is the number line. Where
When
they're
do you
making
start using this? When do you start using the last one?
De este, no puede ser.
late first grade.
Okay.
Once they have enough experience with the base 10 blocks, then you are ready to move on to the visual representation, which is the number line.
Que te mueves para acá, que sí lo pueden empezar a hacer desde primero, pero que primero tiene que tener suficiente experiencia con esto.
Ya. Pero en este, en vez de gráfica, no puede ser el cuadrado que tiene 100.
El cuadrado que tiene 100. ¿Cuál cuadrado?
¿Se lo traigo? Para que se lo muestre.
She says that if we can use, instead of the number lines, if we can use a square that has 100 numbers, I think she's gonna pick it to show you. I don't know.
Hundreds chart, that's okay too. Yeah. But with
Bien,
that being
pero-
said, that's
Yeah.
more like you can utilize hundreds chart too. But the idea with the operations, you want to help children see the jumps that they're making between the numbers. So, for example, I'm gonna see if we can stop sharing and share a different thing.
Que
I'm
los
gonna
cuadros
open
de
up.
100, ¿lo tienes el cuadro de 100? Pero esos son los bloques.
Son estos, son esos chiquititos.
Pero ¿y los cuadros de 100 los tienes? El chart de 100, ese pensé que era el que me ibas a mostrar.
Ah, no, ese de multiplicación,
Ajá.
ese igual lo tengo.
Si quieres traer. Ajá. Gracias. She's asking if she can use this, but what I understood is yes, right? So this is just when they have had enough experience before using the 10 frame. That's what you said. Then you.
Is that the 100 one? It's
No, I think she was talking about that chart. This is 10.
yeah, and that
So this-
should be 100. I think the
Yeah,
bigger
and I
one, but it
think
looks different.
No, this one is a little confusing because I feel that it's not even like,
It's not perfectly aligned with the other one. So I'll put it on like I'll show you what will be better.
no, porque como que no sé, es que aquí como que no se ve. ¿Cuántos tiene? 10, 20, 30, 40, 50, 60, 70, 80. Ah, el problema con este es que no se ven las. Sí, sí. Gracias, Candy.
I'm putting in the chat real quick so you can see.
And this is the 100 chart.
Yeah, but that's more better for counting
Este es mejor
and
para
skip counting and then see the relationship. But when we're doing the addition and subtraction, we want to see how far they're going and how far they're coming back. So I'm gonna let me show you something.
Creo que lo único con este. But this one works or not? Because this one is two tens per line, and I don't
Yeah,
think.
it's just like the way that they designed this tool, it's a little bit confusing because
Okay.
it makes it look like it's organized by 20s, like
Yes.
20, 20, 20, 20. Does that make sense?
Sí,
Look at
sí.
the link that I shared in the
Yeah.
chat.
I'll get them from your link, que nos va a sugerir otros. Ah, ok.
Y-
Ajá.
Because look, not that you
Bueno,
can't
sí.
find like a different, like better deal. I'm just giving this as an example.
Pero ya sí vamos en los
Do you
100.
see the idea with this manipulators
Yes,
is that they can easily see that 10 is in here
yes.
too.
Much better.
Does that make sense? It's like,
Yeah.
so they conceptually see how each,
And more for a guy or a girl that has visual problems, this is much more confusing, right? Because
yeah,
it's not
that's more confusing. Mhm.
si un niño tiene problemas visuales,
Claro.
quizás puede ser un poco más complejo. Los conseguimos. No, we get them.
Sí.
That's okay.
Mhm.
Thank This is wonderful. Qué bueno que se los enseñaste. Sí, no, ya te los encargo.
Hold on. I'm trying to.
¿Desayunaste? Sí. Pero trajiste lunch.
Sí traje y la verdad lo comí mientras estaba.
¿Vale? Ya te lo conté.
Sí, ya.
Te iba a invitar a Carlos a echarnos un lunch saliendo de aquí, aunque sea para festejarte, ya nos vamos, Candy, la Navidad.
Te van a abandonar.
¿Ya comiste? ¿En serio?
Pues comí temprano, como a las eran
¿No
9,
tienes nada de
9,
hambre?
10. Pues ahorita no.
¿No?
No sé si.
Pues aunque sea te invito un smoothie o algo saliendo de aquí para.
Okay.
Yeah.
So
Okay.
for addition and subtraction, it's better to use number line to help children see what is it this one is more like abstract idea, right? Like 10 frame, base 10 blocks are good for concrete level when they're adding and taking away. Once they have that fluency with that, and you want to move on to more abstract ideas where they can quickly make those jumps, number line is better. Because if they like, oh, what is 10 plus 5? Right? So they can make a jump from 0 to 10. So they see like 10 is big, and then make another jump from 10 to adding 5. They can do 1, 2, 3, 4, 5, and this is 15, and that's where you get it. So number line in that sense is a better tool once they have the fluency with the concrete materials, with the base 10 blocks. Move on to number line so they can make those jumps because they understand the numbers now, what they look like, and they don't need to practice. But now they can see the how operations can be represented. And this is with addition, and with subtraction. So 15 minus 5, what is it? And they can start with 15 and make a jump back 5 times and get to 10 and say it's 10, the answer. Because now, why this is an abstract? Because now they're just using the numerals. They no longer have concrete materials to represent the numerals. Now they're using the abstract representations of quantities, which are the numerals, to put it together or take away through making jumps on the number line, backwards or onwards. Does that make sense?
Excellent. Makes sense that they really need to practice a lot before with materials,
Mhm.
before see the
Yeah,
numbers, because
yeah,
otherwise they're
yeah,
symbols. Exactly.
exactly. Use the base 10 blocks a lot, talk about it, and so they can concretely see what that quantity looks like. But then build their fluency with the abstract representation of quantities, which are the numerals, as the next step. Mhm. Okay.
You have to
Uh,
leave today at the half an hour, no? Right? Like in 3 minutes,
yeah,
not?
we said, yeah.
Mhm.
But
No,
I can do another half an hour if you have
perfect.
time and we
Yes,
can finish.
we
We
have
can at least talk about addition and subtraction,
this.
for sure. Okay. Does that sound good for you?
Perfect. Thank you so
Okay.
much.
Mm-hmm.
Sé que puede seguir por media hora esto.
Okay, let me go back. Um, so we kind of talked about this already. So in kindergarten, you can utilize the 10 frame in counting cubes or unifix cubes to work around single digit or within 20 additions and subtractions with the kids. But again, start with the counters first, then move on to 10 frame, and then move on to the abstract representation, which is with a 7 plus 1. And as we're doing these like addition or subtraction problems with the kids, always emphasize, like, oh, like, do we have more now? Do we have less? Like, oh, how many more do you have compared to when you started? When you're saying that, oh, you had like 5 cards and I gave you 2 cards. How many cards do you have now? And then always focus on, is this less? Is this more? So they understand that when you're adding, it gets more. When you take away, which is a subtraction, it gets less. And in the first grade, you can focus on counting by twos and fives to build their understanding of number patterns, which helps them prep for multiplication. Because when they're counting by twos, 2, 4, 6, 8, 10, they're basically 2 times 5, 10. Like because it's counting like 5 times. Subtraction again, within, I think this within 20 up to 100 is appropriate. And in second grade, you can go beyond 200, 100, and you can do 3-digit, 2-digit additions and subtractions with the kids. But again, always follow the same structure, right? Start with the concrete experiences, then visual representations, then abstract representations of the numbers and okay. Another big idea related to operations is comparing and ordering. And what do we mean by that is collections, like meaning that group of numbers can be compared and ordered, and numbers are a useful tool to do that. So I'm gonna skip this video, but what it means is like when you're comparing, this is what I was saying, more or less. Do we have more now? Do we have less now after we added, after we took away, after we did the subtraction? Oh, and that's how we build the conceptual understanding that two numbers can be compared or and then decided whether something is more or less. So when you're doing with kindergarteners, it's important to, again, start with the concrete experiences and then move on to drawing. For example, I can say, oh, I give my tip 4 cards on Monday on Tuesday I gave her 6 cards. Which day I gave her more cards? On Tuesday I gave her more cards, right? Because the 6 is more than 4. But oftentimes, and you can initially start with the cards, physically show them. I gave her 4 cards and then 6 cards. And then they can look at the 2 piles and say, oh yeah, she got more cards on Tuesday. And that's the concrete one. The pictorial representation will be they can draw the cards themselves after you told the story, and they can draw the cards. Monday, 4 cards, Tuesday, 6 cards. And the abstract representation will be introducing them the greater, less than signs, which is like, like a pointing this way and pointing this way, these signs. If it points this way, it means less.
So the last one, the abstract will be pointing to
The one, those
number,
great,
pointing to the number or what? Sorry, the
those greater than, less than signs. The greater than, less than signs. These are like
yeah,
these.
yes,
So
Miguel.
oftentimes people just introduce these signs and they say, oh, it's like an alligator eats you, and that means it's a greater, or if it's this way. But don't talk about those immediately. Instead, have those concrete experiences where you have the cards and ask them to compare and identify which one has more or less, and then move on to pictorial representation when they draw the cards and
Con los
compare.
objetos.
And
Sí,
then
no-
abstract idea comes less when they have that enough
Ujú.
discussion around more or less.
Mucha gente habla de que es como un cocodrilo, pero que no se utilizan hasta que lo hayas practicado físicamente. Excelente.
And this could be a good time to talk about equal sign and not equal sign too in kindergarten. But again, start with talking about what equal sign, the idea of equal means, rather than just showing that equal sign as this. And because part of the reason that we want to avoid immediately showing the equal sign to kids is this. In reality, equal sign means, I'm gonna go to the later PowerPoint.
Candy has a question. Sí,
Yeah.
sí,
Sí, los zapatos que un momento mencionó, usamos unos zapatos, o sea, que no son iguales. Sabemos que son zapatos, pero no son iguales porque tienen características diferentes. A eso se refiere ya, ¿no? Mostrarle, obviamente, los objetos que sean iguales. Ah, estos son iguales, estos son diferentes.
Yeah, Candy says that you are talking about, for example, showing a child that there's this group of shoes that are not similar at all. So before we show these symbols to really show children an example of something concrete that they can see that are different. In this case, shoes. All this group of shoes are different.
Like the number of shoes. Like the number of shoes
of
over here is like more than this
Yeah.
side. They're not equal in amount. Though sometimes what happens when it comes to equal sign is mathematically what equal sign means is like 2 sides are equal in terms of weight, in terms of magnitude. But oftentimes, go ahead.
Ya, o sea que también, o sea, enseñarle que son diferentes, sobre todo se refiere también más que nada a tamaño, o sea, por ejemplo, aquí hay 5 zapatos y aquí hay 3, no son iguales porque no hay 5 y 5. Excelente.
Oftentimes people think that 2 plus 4 equals 6, meaning that after equal sign comes the answer. But in reality, 2 plus 4 is equal to 6. 3 plus 3 can be equal to 4 plus 2, or vice versa. It doesn't mean that after equal sign the answer comes. There's no answer in reality. It just equal sign means that 2 sides are equal. There's no answer necessarily. Does that make sense?
Let me process that.
Yeah.
Está diciendo que la señal de igual no siempre te da una respuesta, sino que no sé si lo entiende, no sé si lo entendí. ¿Tú sí lo entiendes o no? O se lo pregunto otra vez. ¿Entendiste? O sea, que el signo de igual no siempre te da una respuesta. No,
Sí,
I'm
no,
sorry, I didn't understand.
no.
So
So,
yeah,
do
let me
you
tell.
mean that equal sign not always gives you an answer?
It's not an answer. It's
Okay.
it's not a always like it's just not after equal sign. There's no answer technically because mathematically, what equal sign means is two sides are equal in.
Okay.
Does that make sense?
Two,
So
two groups of something
two
are
collections are equal to one another.
okay.
So
Okay.
technically, there's no answer. It just means that their two sides are in balance.
Okay, but which sign are you talking about then?
Equal
The
sign. But that's the
equal.
that's the misconception. People think let me pull a Word document and I'm gonna write like an equation so it's like visually.
Que el símbolo igual no significa una respuesta, que significa dos grupos. Ya, nos va a enseñar ahorita. Yo estoy ahorita
Yeah.
como confundida.
For example, 8 plus
8,
2
no, 2, igual
equal 10. So
a 10.
people often think, and this is a misconception, I had it too until I know better. So people think that after, like, you have two numbers, whatever operation you have, after equal sign comes the answer, right? Not really.
Ok,
Equal sign means that this side is equal to this side. That's what it means. So
ok,
in reality, 8 plus 2 is an answer too,
ok,
because it's their equal. Does that
ok.
make sense?
Yeah, let
So
me
in
explain
that
her.
sense, this is not the equations don't
Yeah,
have to
got
be
it, got it, got it, got it.
okay.
Ok, ok. Lo que ella está diciendo es que este símbolo de igual no es necesariamente una respuesta, que la gente siempre tenemos el mal conocimiento de que el símbolo igual representa una respuesta, pero en realidad lo que significa es la operación, que 8 más 2 es igual a 10, representa el número 10, pero no es la respuesta. No sé si se entiende, está un poco como, yo sé que es lo que que en realidad este símbolo es igual, nos va a dar este total, pero que en realidad este símbolo no significa respuesta, sino igual, ¿sí? Está confuso, pero
Sí.
¿sí le agarraste? Significa igual, o sea que, por ejemplo, que 10 es igual a 8 más 2, o 5 más 5, o 4 más 6, o 7 más 3. Pero entonces que este símbolo no significa cuál es la respuesta, sino
Igualdad.
igual. Es
Igualdad.
que respuesta es distinto a igual.
Claro, ya.
Ya, ok.
Yeah, does that make sense? I know it's so confusing. It just means two sides are equal.
Yo
That's
también.
what it means. But we're often programmed that after equal sign comes
Ya.
the answer, but in reality, they're the same. It's not if that's an
Cambia la
answer, this
palabra.
side is an answer too, because they're equal. It's the same thing. It's just a
Ya,
different way of representing it. But in
excelente, I
terms
got
of
it.
quantity, they are equal each other. And an equal sign means it's a balance. Two sides are in balance with one another. When we put a non-equal sign, that means that two sides are not in balance because one is less, the other one is more, or vice versa.
Okay,
Or two
excellent. We
sides are
got it.
different. Got
We
it?
got it.
I know.
Interesting.
It's just like, actually, it's like, what are you talking about? Because we're like so programmed to think that way. So when
No,
you're
but it makes
introduced,
sense, because
Mhm,
when thinking about children, we want them to understand
mhm.
the meaning of equal. It makes sense
Yeah,
because we have to see it abstract. Entonces, si lo ponemos a los niños, básicamente lo que ellos quieren es que es lo mismo, o sea, no nada más ver, ok, esta es la respuesta, sino qué es lo que te da este total,
Es que, por
¿no?
ejemplo,
Yo
si
creo que...
yo pongo esto,
Ujú.
me pueden decir ellos, Entonces, es que esa no es la respuesta.
Ujú.
Pero ellos están esperando ver esto,
Exactamente.
sino decirles que esto representa lo mismo que esto.
Sí, por eso les tenemos que enseñar los grupos de
Ajá.
cosas. Por eso es tan importante que vean. Perfect.
So when you're using introducing the equal sign in kindergarten, do the same thing what we're doing with the less than or more than signs, or meaning that first have those concrete like experiences, like is this equal to this? So they understand that equal means that they are the same. Both sides are the same. Yeah, because when we introduce these ideas without the conceptual understanding where they have those time that enough time to use the concrete materials, what happens is children just confuses the signs. They don't understand the plus sign, they don't understand the minus sign, they don't understand the equal sign. They will just say, do I put this? Do I put this in here? Because it's just an abstract idea, it's not clear in their mind, rightfully so. But if we keep using these terms with concrete materials first before talking about abstract ideas, and then they build that, they understand. It's quicker for them to understand and make the connection between the existing experience with the abstract representation of that idea. Okay. First grade, again, you focus on more or fewer or less within numbers like 20, comparing numbers up to 100. Second grade, you can do like multiple digit numbers and compare like 3-digit numbers to one another and figure out is 388 is more or less than 255. So the idea is still the same. They're comparing when in the context of more or less, but the numbers that they're comparing is getting more complex as they get older. But if you have a second grader is not able to do 3-digit comparison, that means that you need to go back to 2-digit numbers. And if they're not able to do 2-digit, then go back to single digit and build your way up from there. This is all typically what they should be able to do. And if they're not able to do, then go back to 2-digit, go back to single digit, and then go from there. This big idea is more related to division. It's a fair share, meaning that a quantity, a whole, can be partitioned or decomposed into equal size in pieces or parts. And we call this a fair share. So when you're dividing a number in elementary grades, we always focus on whole numbers. We don't do fractions yet. So for things to be divided into the smaller parts, it has to be a whole number, meaning that 30. We don't divide 31 by 5 in second grade, right? Because then it will be more complicated. It's going to be like 5 point, like whatever, because it will have fractions in it. So we call this a fair share, that everyone, if you divide a whole into equal parts, everyone will get the same amount. Like, for example, in here, there are like 12 chocolates. 3 friends want to share them. How do they divide the chocolates to be fair? Yeah.
We have a question. So
Mhm.
divisions, that what you're saying is to do it just in number pairs, on pair numbers, or
Whole numbers. So you
whole numbers?
divide whatever you're dividing is like up to second grade. Like past second grade, you can't talk about fractions. But if you are doing division activities in second grade and with small numbers, it has to be based on whole numbers, meaning that when you have a number, you divide by another number, the resulting numbers needs to be a whole number. It cannot be 3.5, 3.2. So you always divide 30 by 5, for example, and the result is 6. But you
I see.
shouldn't, with second graders, you shouldn't be dividing 31 by 5, and then you
Okay.
have 6.2. That's
Oh,
not the
got it, got
method
it.
of Got it?
Got it.
So it needs to be
Yes.
whole numbers. It cannot be any
Sí.
point something.
Sí, lo que no se puede hacer más bien es partir, por ejemplo, 31 entre 2 porque va a ser .5. O sea que lo que no se pueden son las mitades del número.
Ajá,
No, números enteros sí. O sea, todos los números,
No
pero
digo
nada más.
números pares, no,
No, no importa que no
impares.
sean pares. Sí pueden ser impares. Lo que no son las fracciones. O sea, que no vaya a ser 31.5 o 33.4. O sea, que tiene que ser números enteros. Yo pensaba también que nada más pares o impares. No, que está bien, pero que eso hasta segundo de primaria, que ya para partir de tercero. So then it will be until third grade when you start doing divisions with the
Fractions. Yeah.
fractions hasta
Mhm.
tercero de primaria. Pero bueno, okay, perfect,
Yeah.
perfect.
Yeah, so what are some general expectations to recap per grade level is like from pre-K to second grade. They, again, regardless of their grade level, they need to work on a lot of time on addition and subtraction of whole numbers and the relationship between the two numbers. When we add, it gets bigger. When take away, it gets less. Again, in pre-K, they're working numbers up to 10, in kindergarten up to 20, in first grade up to 100, and second grade up to like 999, like three-digit numbers. But they keep looking at the relationship between adding and taking away with larger numbers at each grade level. But the concept doesn't change, right? And related to
One
multiplication and
second, please. One
yeah,
second.
No,
yeah.
no, digo, yo digo, no, está bien el nivel, pero por ejemplo, yo considerar también que el niño pueda hacerlo,
Sí,
¿no?
sí.
Porque el niño tiene que reconocer las cantidades, por ejemplo, bueno, vamos a ver, por ejemplo, Paloma. Paloma todavía no puedo trabajar con Paloma hasta el 100, porque todavía no ha reconocido, por ejemplo, los números de 10, 20,
Todavía no.
exactamente.
So Candy is saying that, for example, with Paloma, she cannot move to 1,000. No, al 1,000, no, al 100, ¿verdad?
100.
She cannot move to 100 because she doesn't recognize yet like tens, twenties, o sea, tens, 10 ya los reconoce. ¿o no?
10,
10.
sí, pero
Just 10.
después todavía
But
está
she
costando.
doesn't recognize after 10, for example.
How old is she? What grade level is she?
She is in first grade.
Okay.
Ella está
So
Ujú.
yeah, so she needs to build fluency numbers up to 20, maybe by using the 10 frame,
hasta los
and
20 y que utilices el marco
and
de
then
10.
really have spent some time on that for like maybe a few months even, and then move on to bigger numbers. But we need to build her fluency with up numbers up to 20.
Ajá. Okay,
Mhm.
yeah. Okay,
Yeah.
perfect. Yes, o sea que no se puede mover hasta después, hasta que tenga la
Consolidado
fluencia,
todo.
consolidado, sí. Entonces ella necesita utilizar más el marco de 10.
Ujú.
Todavía ahí, antes de llegar a esto.
Sí.
Que practique todas las cosas. So she needs to practice 10 frame much more, right?
More
Or maybe
concrete like counters and 10 frame, and then move on to base 10 blocks when she has like really have fluency numbers up to 20.
would you do
Yeah.
sorting with her even with the natural materials? Because she didn't have good math base, for example.
Mhm.
So would
Yeah.
you go back even to that, like to do sorting with the materials, natural materials, with leaves, with everything?
I mean,
Or
I think you can use counters, like you can use the count leaves or count like rocks and things like that. But within like 20, focus on, and then move on to, I think she should be beyond like sorting, I'll say.
yes, she's beyond
Yeah.
sorting for sure.
Yeah, I wouldn't go
Okay.
to sorting, but I will go to like 10 frame.
10
And
frame.
so she can see the connections between numbers within 10 and then within 20 by using two 10 frames. And then once she has that fluency, then move on
When you
to Mhm.
when you use the 10 frame, would you use it to think about real life things, or you just use the tokens and that's it, and you don't talk about
Yeah, when
situations?
yeah, so this is not a necessarily like a word problem, but it's like a game. So you can have a die or dice, and then you can roll it at what number. Okay, we fill it out in the 10 frame, 7. And then you can, how many more do we need to make it 10? And then she can count like 3. And then you can say, so 7, if we add 3 to 7, that makes 10. You know, that kind of thing.
Ok, excelente, Vilga, thank you so much. Que no necesita
No.
regresarse a clasificar porque ella ya está más allá.
Sí.
Nada más es el marco de 10.
So when you're doing addition, you can use manipulatives like counters. You can use the number path when they have enough experience with the manipulatives like these. You can move on to number path. You can do rack and rack to move it along, to join and take away kind of activities. With addition, it's important that we focus on part whole, that meaning that two numbers create like a larger number, and we call that part whole. The whole is 11 in this example.
Números, por
6 and
ejemplo,
5 makes 11.
tener un número grande o 6 y 5, o sea que estos son manipulativos que nos ayudan, por ejemplo, a entender que esta parte y esta parte forman un número total, ¿no? O sea que 5 más 3 más 2, lo que no entiendo es esto, pero part whole 6. I understand everything except of the graphic. Do I need to understand? Oh, yeah, I see. Sí, mira, por ejemplo, 3 más 7.
Hacen la cantidad.
Actividades de
Sí.
sumas. Ajá, manipulativo. Okay.
Yeah, and this imagery, like where there's like a circle and two circles coming out, that's also called number bounds. Another way of saying part whole, that like 5, 3, and 2 makes 5. 5, 3 and 2 looks like this, makes 5 too.
5, 3. Okay. Ajá. 3 and 2 make 5, but
Yeah.
5, 3 make 8, right?
Yeah, this is like both like 5, 3, and 2, 5, 3, and 2. Yeah.
Okay. Eso sí que lo tienen en distintas formas. O sea que este es el total,
Mismo
el de
resultado,
arriba. el
pero
total.
diferentes,
Ajá.
sí.
Perfect.
For subtraction activities, you can use the 10 frame again with the like kindergarteners, and you can say, oh, like we have like 5 friends who came for the sleepover, 2 friends left. Like how many friends
Los amigos
stayed for
no.
sleepover? You can use dominoes too, that they help with they can pick a domino and then create like a number problem. Oh, like can you create like addition problem? Can you create like a subtraction? They can say, oh, there were 6 cupcakes and 6 friends ate all the cupcakes, so there's nothing left, 0 cupcakes left. So they can create like a story about the number problem that they come up with. Does that make
Yeah.
sense? Okay.
Yeah, but you don't play domino. You just use it as a...
Use it. So you can even like put it in a bag, and they can pick up a domino. And then there are always like 2 numbers, or there's like 1 number and there's nothing, which is a number 2, 0. And then you can ask them, what kind of like number problem can you come up with this? And this could be a good one for like first graders to like, because they ideally they have some experience with numbers. And then they can come up with like stories. You can come up with stories to model it to them first, and then you can ask them to come up with their own story.
Ok, so let me explain. Que también puedes utilizar las fichas de dominó, que nada más simplemente para que ellos te cuenten, por ejemplo, historias, ¿no? Por ejemplo, aquí habían 6 amigos y llegaron 6 pasteles para ellos. Entonces ella puede sacar una ficha, o los niños que estén y que te pueden decir, bueno, aquí que te inventen una historia, ¿no? Aquí hay 4 manzanas, ya ves que siempre hay o sea, 2 opciones, ¿no? Y aquí hay 6 sillas, o sea, que te hablen acerca de lo que ven y que te generen una historia, o que puedes, o sea, crear historias a partir de la ficha del dominó. Excelente.
You can use like linking cubes for comparison to like which one has more, which one is less. You can use a number line to do those jumps that we talked about, backwards and onwards, and those are helpful too. I think I need to stop here.
Yes, please.
And then
Yes,
we can
thank you so
continue
much.
from
Thank you so
there.
much for all your help. We really
Oh, no,
appreciate